So this is 2.5 part 2. So this slide for the first page on part 2 is the same as the first one on part 1. Talks about our fundamental theorem of algebra. So the same thing applies, that whatever our highest degree is, if we have x to the 4th power, we're going to have 4 zeros in our answer. For part 2, we're working backwards, so it's going to give us the zeros, and we're going to come up with a polynomial. So if we have 4 zeros in our answer, we know our polynomial is going to be x to the 4th power. So super important for this section, whenever we have complex zeros, they occur in pairs. So we'll always have the conjugate of our complex zero be a 0 also. So if 2i is a 0, its conjugate, which would be negative 2i, is also 0. So complex zeros occur in conjugate pairs. So that is, if we have an I, that means that negative I will also be one of the zeros. Or if we had, like, let's say square root 5, negative square root 5 would also be a 0. So when finding the polynomial, given the zeros, we always have to double check to see if we're missing any zeros. Here it tells us that we have a 4th degree polynomial. So we know we need 4 zeros, but not all the questions are always going to tell us that it's a 4th degree polynomial. We're just going to have to look at our zeros, see if we have any conjugates, and make sure we write the pairs of them. So do we have any complex numbers here? 3i. So we know that the conjugate of that is also a 0, so that would be negative 3i. So you always have to check and see if you have i's or if you have square roots, because the conjugates will also be a 0 there. So now we're working backwards. So we're doing the same thing from part 1, just completely reversed. So these are our zeros. It's saying x is equal to -1, -1, 3i, and negative 3i. So if we put this into our linear factorization, we would get x plus 1, x plus 1, x minus 3i, and x plus 3i. So notice how we always change the sign when you put it into linear factorization, because if I were to solve this, x plus 1 is equal to 0, subtract 1 on both sides, x is equal to -1. So the sign always flips. So it's always x minus, and then you just put your 0 in there. All right, from here, we have to FOIL it all out, and then we'll get our polynomial. So it always helps to FOIL the complex part first. So I would FOIL the 2 conjugates here. Because when you FOIL conjugates, the outers and inners cancel, so then it's just going to be 2 terms. Whereas if I FOILed the first 2, I would get a trinomial. So I'm going to FOIL the second 2 binomials here. So a little shortcut when multiplying complex numbers is that you can square the first term and minus the square of the second term. So it's like multiplying the first and the last, because the outers and inners cancel. So x times x would be x squared. It's always minus in the middle. And then 3i times 3i would be 9i squared. If you wanted to FOIL these all out to the first, outer, inner, last, you'll get the same thing. It's just a shortcut, so you're skipping a step. What does the I squared turn into? -1. So this makes it a positive 9. So this is x squared plus 9. So we just multiplied those together. Next, I'm going to multiply x plus 1 and x plus 1. So these 2. So again, we're just FOILing x squared plus x plus 1. We have to combine like terms next. This would be x squared plus 2x plus 1. And then I want to FOIL these 2 together here. These 2. So I'm just going to rewrite them next to each other. X squared plus 2x plus 1 times x squared plus 9. So I just rewrote them here, because I'm going to have to multiply. So we're foiling, but one of them has 3 terms. So you just have to make sure that everything in your first group gets multiplied to everything in the second. So I'm going to start with x squared. X squared times x squared would be what? X to the 4th. What's x squared times 9? So plus 9x squared. Then I'm going to move on to the second term here. So 2x times x squared is 2x cubed, and 2x times 9? 18x. And then I'm going to move on to the third. So I have 1 times x squared, and then 1 times 9, 9. And then from here, I have to combine like terms. So I have x to the 4th power, only one of those. Next, I'm going to move on to x cubed, so that would be plus 2x cubed. I'm going to add my x squared. So I have 9x squared plus x squared would be plus 10x squared, then plus 18x, then plus 9. And then whenever you write your answer, you have to put equals 0, because it gave us the zeros to start. So this would just be our polynomial equals 0. So looking at number 1, are we missing any zeros here? No. So next step we need to do is write our linear factorization. So this would be x plus 5. I have x minus 2, and then how do you think I can represent that 0? Just x on the outside. I'm just going to put it out front because that'll be the easiest thing to multiply, so I'm going to save that for the end. So first thing I want to do is FOIL these two together. So I'd have x squared. The outsides would be minus 2x, insides are plus 5x, lasts are minus 10. I can combine my like terms. So x squared minus or plus 3x minus 10. And then I can just distribute that x to everything inside my parentheses. So this would be x cubed plus 3x squared minus 10x equals 0, and that's our answer. One way that you can check, just to see if you multiplied it out mildly correctly, is if we have x cubed in our answer, we have 3 answers that we started with. So if you have 3 answers, you know your answer is going to have, if you have 3 zeros, you know your answer is going to have x to the 3rd power. Santiago. All right, let's take a look at number 2. What are we missing for number 2? Negative square root 3. Awesome. Because we had that positive square root 3, we need its pair. So then what's my linear factorization going to be? X plus 5, x minus square root 3, and x plus square root 3. So the first thing I'm going to do is multiply my complex pair here. Since they're conjugates, I can just square the first one, so that would be x squared, square the second one. What's square root of 3 times square root of 3? 3. It would be square root of 9. Square root of 9 is 3. So that's what I get when I multiply those two out.
Why wouldn't
All right, next I'm going to multiply the x plus 5 in there with it. So here I just have to FOIL. So the first ones would be x times x squared, which is x cubed. Then the outsides, minus 3x. The insides, plus 5x squared. The outsides would be minus 15. Do I have any like terms? Nope, but I need to write it in standard form, so it'll be x cubed plus 5x squared minus 3x minus 15 equals 0. Yes. What zeros am I missing for number 4? Negative 3i and 2 minus I. So when I write my linear factors, I'm going to have x plus 4. I like to write my pairs together I like to multiply my pairs together, so I'm going to write them next to each other so it's going to be easier to see. That's why I wrote the 4 first, just because that's going to be the easiest to multiply at the end. So next I'm going to do x minus 3i. Its conjugate was x plus 3i. Then I'm going to have x minus 2 plus I and x minus 2 minus I. So I'm going to multiply these two together first. So I want to distribute the negative here, and I'm going to have to distribute it here and here. So this is going to be x minus 2 minus I, and this is going to be x minus 2 plus I. Now, are these conjugates of each other? Mm-hmm. Yes, but what's our first term?
Oh, you have to distribute that negative?
Yes.
What do you mean?
So like conjugates, we have 2 plus I, 2 minus I. Like where the first number stays the same, the sign changes, and then we have the imaginary part. So what's our first term? What would that first number be? X minus 2 here, because that's the same in both of them. The sign here in the middle changes, so we have minus, then plus, and then the I. So x minus 2 is our first term. Now, since these are conjugates, I can just square the first one, square the second. So I have x minus 2 squared minus I squared. So now we have to do x minus 2 squared. So how do I do that? FOIL. So x squared minus 2x minus 2x plus 4. So if it helps, write it next to each other. This is x minus 2 times x minus 2. And we still have that minus I squared. What does the I squared turn into? Negative 1, so that would make this a plus 1. Now I can combine my like terms. I have x squared minus 4x plus 5. So I just FOILed this part out. Yep, so now I'm going to do this pair here. So these are conjugates. So I'm going to square the first one. That would be x squared minus the square of the second. So what would come next? 9i squared. What does I squared turn into? Negative 1. So that would make this a plus 9. So this here is x squared plus 9. So I'm going to multiply that now with x plus 4. So I just brought this one down because I have to multiply these two together. So I have to FOIL. X times x squared is x to the third power. X times 9, 9x. 4 times x squared. And 4 times 9, 36. Do I have any like terms? Nope. So I'm just going to rewrite this in standard form down here with the other one that I have to multiply it still to. So I have x cubed plus 4x squared plus 9x plus 36. So now I have to multiply these two together. All right, so now I have to multiply these two. So I just have to make sure everything in the first parentheses gets multiplied to everything in the second. So I'm going to start with x cubed. X cubed times x squared. So that would be x to the fifth. X cubed times negative 4x would be negative 4x to the fourth power. X cubed times 5 would be plus 5x cubed. Now let's move on to 4x squared. 4x squared times x squared would be 4x to the fourth power. 4x squared times negative 4x is negative 16x to the third power. 4x squared times 5 would be plus 20x squared. Now let's move on to 9x. 9x times x squared would be plus 9x cubed. 9x times negative 4x would be negative 36x squared. 9x times 5 is plus 45x. Almost done.
So this is why there's only 5 questions.
Yeah. Next, we're going to look at 36. So 36 times x squared is 36x squared.
Wow.
36 times negative 4x, negative 144. Yeah, 144x. And 36 times 5.
Are we going to use a calculator?
Nope. And from here, we have to combine our like terms. So x to the fifth power is going to be my first one. Next, I'm going to look for any x to the fourth power. I have negative 4x to the fourth power and positive 4x to the fourth power, so those just cancel each other out. Then I have x cubed, so I have 5x cubed, negative 16x cubed, and 9. So that would be 5 minus 16 plus 9, negative 2x cubed.
Wait, how did you just cancel out all those?
I'm just combining them down here. So x to the fifth power, I rewrote it. X to the fourth power, I had negative 4x, positive 4x, so those just canceled each other out.
Okay.
Then I'm combining 5x cubed, 4x cubed, no, 5x, negative 16, and 9, so that became negative 2.
Okay.
Now moving on to x squared. I have a negative 36x squared and a positive 36x squared, so those cancel. And then I have plus 20x squared. So there's that. Then I have my x's. So 45x minus 144x be negative 99x. And then plus 180. I always like to cross them out as I go just to make sure I got everything when I rewrote it. Then this is equal to 0, and that's my answer.